Welcome back. I haven't done a video in a long time simply because I've been super busy. So today I thought I'd give you an update on the SIGROC. I did manage to build it for the Raspberry Pi, but it was very difficult to do. I ended up building it in a Raspberry Pi VM under QEMU, and it took a long time to compile and get it right. Somewhere I have the archive. I don't know where I put it. But all I can suggest is if the SIGROC is already in there at whatever version, just use that version. You don't really want to build this. It's horrible. It's easier on the PC side, but it still takes time to compile. It runs through a huge test harness, and that's where I ran into a lot of issues with it. But today I think I'm going to talk about my new pet project, basically PlatformIO. So I have Visual Studio Code, yes, the one from Microsoft, installed into my Linux, a VM on my Windows, and actually on a Raspberry Pi. And I've installed the PlatformIO via the extensions right here. On the right, if you look on the left, there's that little three square blocks with this block hanging off it. This guy right here. So if you go into here, PlatformIO, there it is, PlatformIO IDE. Now the reason I'm playing in this environment is because it has massive support for all sorts of IoT boards. So this little board down here, the Nano, for example, I'm playing with, or the Mega, or I have plugged in right now, which I'll just unplug, the Uno. Okay. So one of the things I wanted was a different platform than the Arduino IDE platform. Now there's a couple of gotchas when you do this. You have to convert your project into PlatformIO, the way they do things. So let's go back up to here to our code. Now I already have a workspace full of Arduino projects, so I'm going to load that up, but I'm going to add another project in as the demonstration. So we go to File, and I am going to open Recent, and I am going to open my Arduino examples workspace. So as you can see, I've got a ton of projects here. Now, what I do is either through console or the file manager, I need to check what the next Arduino project I'm going to install into this tree. So I put everything I do work on in work. So we were in 04, and the last one was physical pixel. So we have read ASCII string. Now, I'm a lazy bastard and I don't want to type, so I'm going to just call rename, first of all, Control C, so that I have the name of the directory inside of my clipboard. I'm going to need it later. Okay. Now, another thing you might want to do is up to you. By default, PlatformIO stores its projects in a different directory than you might think. I believe it's Home, User, Documents, PlatformIO, Projects. I didn't like that, so I changed it. So if you go here to the PlatformIO terminal, so now it says PlatformIO CLI, and we go and run this command. PIO settings, set project dir, and where we want the projects. And when we do that, like so, you can see we now are, instead of this tree, Home, William, Documents, PlatformIO Projects, we're Home, William, Work, PlatformIO. I tend to do all my stuff that I want to manipulate in my work directory. I save the Documents directory for, Documents. I really don't like the concept, and this is in Windows too, I don't like the concept where your documents directory ends up with source code trees and other stupid shit like this. It's really dumb, right? If I'm going to code somewhere, and I might go into my work directory and I might make a subfolder called C programs, another one C++ programs, another one Python, right? And then in it would have projects. You get the idea. I prefer to divide and conquer my tree and not plaster everything in certain areas. Anyway, so once we set inside, if we want to change our thing, we don't actually need this PlatformIO. We can go downstairs. There's a home button down here, right there. Right? It says PlatformIO Home. When we bring it up, this is what we see. Well, we're going to do import Arduino project. So we click it. First thing it's going to ask us, what board? Well, let's say Nano. Well, there's 3 nanos here. This nano right here, without the string after it, is the old bootloader. And this one here, of course, is the new bootloader. The real big difference I read is speed. Not the actual Atmel on top, nothing like that, just speed. The bootloader in here, 57K is basically bootloader here, 115K speed. So, of course, you can load code faster into the new bootloader than you can into the old bootloader. But my nanos, I know, have old bootloaders on them. So I'll pick it. Now, I already have the Arduino IDE installed right there. So I'm going to tell it, borrow the libraries. Now, down here in the tree, we need to find that Arduino project that we're going to import. So if we go and look, Willem, work, Arduino. Now, examples. Now, since I'm going in here all the time, let's click this fat star right here. Toggle favorite. Okay? So we know that these examples go directly to this folder. And I already added the projects tree in PlatformIO as another quickie. Although they also have it here. Yeah, same thing, right? So I was in number 4, communication. And last one I did is physical pixel. So we're going to do read ASCII string. Click on it. Okay? And we say import. What this will do for us is a number of things. Oh, I don't need Mr. Blink. Let's go down to the bottom here. And number of things. And first of all, we have our first issue. What an ugly name for a folder. And if you look at this, where's the rename the folder? Doesn't exist. So what we're going to do here is file. We're going to close this particular folder. Actually, we're going to close the word. This is the tricky part. If the folder was standalone, we could close the folder. Okay, remove folder from workspace. We'll do it that way. We'll go back to our Explorer here, and we'll back up, and we will go into PlatformIO projects, and there's that gobbledygook folder. I don't like it, so we rename it. Remember that cut and paste I did? 04-Control-V. Enter. Okay. Now we go back into here and we say open folder. And I will take that read ASCII string folder. Okay. Now I noticed I just have a problem here. We're not in our thing anymore. We're not in our workspace. So let's close that off for a sec here. And let's open our workspace again. I think sometimes Visual Studio could do this a little better. Open recent. This guy here. In this case, I'm going to go here and add a folder to a workspace. And do it this way. There we go. Add. Now it's in here. I also notice that Visual Studio Code likes to I don't know, somehow remember vaguely that it had another folder open, even though I don't have it open. All right, so we go down here, and we go to source. Our first issue is we have to convert this to a C++ file, which is simply renaming it. CPP. Okay, let's open it up. Now, you see there's problems here, right? 5 of them. Okay, this is one I've come across and I don't know why it occurs. For some reason, in the VSCode CPP file, it thinks these aren't comments upstairs here. But if you do this, save, problem's fixed. Go figure. This is a random thing that I find that sometimes just happens in Visual Studio Code, and I don't know why. Have no idea. And I don't feel like troubleshooting it. Now, let's go back to strings CPP here, reads ASCII strings. Now, one thing you could run into in your install, and this is all how the IntelliCode, IntelliSense, pathfinding, everything works for the Visual Studio Code. Sometimes you'll get this effect where it says, I don't know what pin mode is. This line doesn't come up. It doesn't say void pin mode, unsigned int 8, blah, blah, blah. Right? It just says, what the heck is pin mode? I don't know, undefined. If you get this case, what you have to do in here is go include, just like that. Save our file. Right? Because in the INO file, you'll notice that it's not needed. It's just simply part of the environment in Arduino's IDE. That guy there. So, but this is more a classical C++, C editing programming environment. So it's expecting you to follow the rules basically. And sometimes this guy cheats at the rules, this guy doesn't, and will whine at you. Usually because IntelliSense or the IntelliCode engines go and say, I'm sorry, it's not there. Well, that solves it. Okay? Now, this CPP properties JSON, the other thing you're going to find with it that will happen, and I have this not on this platform so far, but on my VM in my Raspberry Pi, when I do that project thing and I import and stuff like that, it doesn't auto fix this part right here in the path. Right there. It still has the gobbledygook, blah, 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 nanomega, blah, blah, blah path in there. Now, there are a couple of ways of fixing it. They warn you not to edit in here, but you can actually edit. You can go, highlight the thing in question that this is the problem and go Control H, like so, and then do a replacement with what you really want in the path. In my case, I don't have to fix anything. I already know it's 04 read. But this could be the gobbledygook path. This could be the regular path. And then you can click this little button, replace all instances of it. Then Control S the file, and all of a sudden a bunch of warnings about I can't find anything go away. Now, the other approach to this is there's an alien over here. No, he's not from Mars. He's from Platform. If you go into the alien, right, and you go to default project tasks, and we're just going to shrink this a little bit here like that. And we go to miscellaneous, rebuild the IntelliSense index. Ta-da! It rebuilt the thing. Okay. Now, you might notice also, sometimes we bump back out to the bash shell. Click your little PlatformIO so you're in the PlatformIO shell. Right? Otherwise, you can't do platform straight commands or whatever. But that fixes the path issue generally. You get confusion where it can't find, or you've added something into your project tree and it doesn't know where it is. You might add something into the lib directory, or you might add another source file, or you're adding something into the include directory here, a header, and it can't find it over here. Even though you did, let's say angle brackets header file.h angle bracket, right? But this will help you fix. Now, again, comments not permitted in blah, blah, blah. See, I'm going to have to look into this, but this is a very annoying thing to have happen. Right? So it's saying analog read serial. So it's complaining about another file completely. Right? So if we go to 01 analog read serial, VSCode, this CPP, it's complaining about the same damn thing. Right? There, fixed. I hit save a few times. Right? Let's go back down to our read ASCII one, where we were. Okay, so change the file to CPP. Add this if you need to. The include statement. Correct this if you need to, or have it rebuilt. Okay. Now, this PIO directory here deals with libraries. Now, we need a set of projects here to demonstrate this. So I do have it. It won't run properly, but because I'm not on a Raspberry Pi for this. Okay? So I'm going to close this workspace off. And I'm going to open another workspace. Work. PlatformIO. Projects. Let me scroll down. We have projects code workspace here. Okay, so what this stuff is here, this was a bunch of Rgb Matrix demo code from a library called Rgb Matrix something. This is all Arduino code. But we had to do a few things. Now, this PIO directory, for example, as you can see, it actually has a libdeps in there. And then based off the board, it has the AdaFruit libraries. The Rgb default matrix panel library, AdaFruit, blah, blah, blah. Now you're wondering, well, in the Arduino IDE, there's a library manager. Well, there's a library manager here too. Ta-da, a library manager. Right? And we can go to installed, for example, and we can see Ada. Let's see. No? Yes? Maybe? Well, what's the libraries? This guy I find a bit finicky finding files. I'm not even sure why. Uno. Oh, case sensitivity here. AdaFruit. Let's see if we can find the AdaFruits. Nope. Well, for some reason, it's not showing it up. That's very disappointing. Why? Built-in. No. Installed. Search for everything. Filter libraries. My name. Registry. AdaFruit. Let's look in the master database. Okay, so AdaFruit bus.io. Okay, so for some reason, in this GFX demo, it thinks it's not installed. Now, this could be because I cut and paste this whole directory. So something might not be right. Okay. So we'll add it to the project. We'll select the project. That's not the project I wanted. Okay. Now, definitely I have a screwed up tree somehow. So I'm going to try the other alien command in here. Default, advanced, no, not advanced, miscellaneous. update project libraries. And I'm going to try update all, just make sure. So go back to here, and the problem is I'm not seeing all my projects, right? So I might have to fix this on this machine. Let's see if I can do this rather quickly. Remove folder from workspace. Remove folder from workspace. Remove folder from workspace. 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 Okay. So let's us add a folder. And we will go here to projects, and I will take the matrix one, and I'll say OK. And then I will save it as a new workspace. Save workspace as, and we'll call it Rgb workspace. Save. Okay, so let's add a folder to the workspace. The demo. Add a folder to the workspace. Plasma. Add a folder to the workspace. Other plasma. The sizes on the end are the panel sizes. 16 by 32, 32 by 32. I actually got this working up to 64 by 64 actually. I have all types of panels here. Scroll text, add. I might have to do this with the Arduino, but I'll do that later. What did I just say? Add scroll text? Yeah, text colors. I wonder if I can do an multiple folder load. Let's shrink the folders. So text color, text shapes, test shapes. 32 by 64. Did I get them all? Folder to workspace. Let's see. I got the matrix one. Oh, there's two more right there. The color wheels. Add them. Yes, we can do multiples. Okay, so let us check again the library thingy, because I suspect I blew it up. So we know that in PIO we have the libdeps, blah, blah, blah. So let us go back to PlatformIO's home. And actuality, I might have done this wrong. Sometimes you have to load it through there. Let me do something here. Okay. We're going to go this way. Open project. Projects. Color wheel. Open color wheel. Okay. Let's see if we can open multiple projects in here. That'll be cool if we can do that. So color wheel. No, it's going to go right away into a color wheel directory. Ta-da. Okay, home. Open projects. So we did the two color wheels. Let's do that one. So I did the panel GFX. Let's do the plasma. You'd think I'd keep the home page open, but it doesn't. It does and it doesn't. Plasma 32. Shrink the windows. Open the house. Go open project. You know, I'll do all this and it won't work. Scroll text. Open text. Shrink the windows. Do the home. Open the project. Go to the projects. I did the scroll text, test colors, do the house, open the project, do the projects, test shapes, open the house, open the project. This is just adding all the stuff back into a new workplace, basically. I just did test shapes 16 by 32. So test shapes 32 by 32. Enter. One more to go. Window. Open project. Projects. Test shape 32 by 64. Okie dokie. Let's see if our library stuff works this time. Home. Libraries. Installed. There we go. So I was correct. Cut and pasting the stuff, I probably missed a control file that was in another directory, because I do know there's that .platformIO, and it might be keeping data about that. So, but there we go. So if we do GFX demo, for example, and we look at PIO, libdeps, Uno, the reason you see a 3 here is because you got 3 boards. All have this library in it. Okay. Cool thing about this is if you click on one of these libraries, let's go do the Rgb Matrix Panel one. They show the examples. These examples come out of this library. This color wheel, for example. Right? See all these guys? They all are here. I just took them out of this demo directory and made them as projects in PlatformIO, which is kind of handy. Okay. But you can see these are the 2 files. This is the INO. I had to convert the INO file, like I stated before, into a CPP file. Okay. Now, look at all the orange that just happened right now. Yada, 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 yada. It's complaining up the yang yang. VSCode is complaining. If we go to CP properties JSON, right, you see, I believe, give me a console here for a sec. So it says 65 problems. Okay. So color wheel. Okay. If you actually wait for a while, this thing will actually eventually catch up to all this. Or you could just click on the properties page, and guess what? It fixes itself, because it's reparsing everything. So if I click on color wheel, VSCode, CPP, it corrects itself. But the path, it doesn't like the path. Matrix 2 source, that's wrong. Right? So we know that that's not the right path. This is where I say this is a problem. So let's see if we can rebuild this by our little alien here without having to do any edits. So miscellaneous. See, this is where the problem is. I know it's not Matrix 2. If we bring up our platform projects, right? This is color wheel program 3232. Color wheel program 3232. Okay. So if we right click and say rename, Control C, put it in our clipboard, throw that away for a sec. And we come over here and we double click on this matrix 2 and go Control H, Control V, all instances, Control S. Oh look, color wheel's corrected now. Right? Color wheel, GFX demo. This one's wrong. Let's see. Does it have the wrong? In this case, just needed a refresh of opening the file. And actually, if we watch this, it might actually self-correct itself over time. But I'm an impatient person. I know that this should correct itself. Like so. I think whatever timing loop is in here to actually parse these files and check them out is a little on the slow side. Oh, look at that. It cleared a whole bunch of them in a fell swoop. Let's go to this one here and see what it's complaining about. Again, wrong property. So it's test shape 3264. I'm going to go to Dolphin here. And I'm looking for test shapes 3264 right there. I'll rename. I'll Control C, put it in the clipboard. And then I'll go over here. Control H. Control V. Fix them all. Control S. Da-da. Now all our stuff is correct. So you can also manage boards from in here. But this gets a little tricky. Let's say we want to add the other Nano, the old Nano. Sorry, the new Nano. So we go find Mr. Nano. So we want to add new bootloader Nano. Whoops, did I click one clicky wrong? I think I did. Let's do this again. Boards, new Nano, unit testing, debug on board, get it now. Well, it puts it up on the web thing. What we want to do though is copy it to the clipboard. I believe this is what you do. So we need to add this board to our code. And there was a button. Where did I see that again? Okay, installed, embedded, desktop, frameworks, updates. No, we don't care about any of that. Our damn devices. Platforms, no, boards. Projects, here we go. I think this is where you did. Let's see, find our GFX demo one. There. Here we go. So here's the tabs for all the boards. We're going to add a configuration. Now, as I said, there's two ways of really doing a lot of things in here. This one is the way they would have you do it. So environment name, we're going to call this Nano New. Okay, to represent the new bootloader. In the option, we are going to pick a board. Board, Control V. Okay. Ta-da. We have that, but we're not done yet. Click for another option. We need a framework. And this is the tricky part. You have to remember what frameworks are versus what are things. So I usually go to an existing one, like the Uno, actually to the PlatformIO file itself. Where are you? So platform framework. So I know it's this one for Arduino. So home v Arduino. So we know we have an environment, we have a platform. So we have the framework, we need the platform packages. And one other little bit. Oh, I'm sorry, we need platform, not platform packages. So this guy here, just delete it. So we've got 3 of our 4 lines that are going to be in this INI file. But we still need this. So lib extra dirs, right? So when you type up here, you just go looking for lib extra dirs, like so. Okay. Save it. There you go. Now it's in here. You might think, wow, gee, that's a lot of work. It is. You could also do this. As I said, clone, clone, clone. This is, I find, a lot easier. Just go like this. We know we need to give it a name. I'll go dash new. And board. It just happens to be practically the same name with the word new on the end. Everything else is the same. We don't need this block anymore. So now we have old nano. And by the way, I think I'll rename this nano. Well, we better do that. And this nano better be labeled that one. There we go. So we got the old bootloader nano, the new bootloader nano, the Uno, and the Mega. Control S. Oh, something in there are 2 saves. There's a Control Shift K and then an S to save without changing the format, and then there is a Control S that saves and then auto formats code. So if you don't want the auto format code crap, if you go F1, I believe it's format. No. What was it? Formatter. Save without formatting. Hit this little wrench right here on the end and reset the keystroke. Okay. So I changed the previous keystroke to just Control S. The reason for that is the damn JSON files. This is kind of a bad example, but sometimes when you're writing these damn things, people say, well, do it this way, do it that way. I actually prefer this, where my brackets line up. Right? Like that. It won't matter in this particular file because it'll probably get reset on us. Like when it reparses and decides to reset this file, this will move back up here. But if you have custom JSON or stuff that doesn't do that, doesn't have this warning, don't write blah blah crap at the top, you're going to find that maybe you don't like the formatting. And this, by the way, applies to any of the file types. The C file types, the CPP file types, the Python. You might not like the way they do it. So let's just exit this and bring up the GFX demo CX code. So when I had this running on the VM and the Pi, the only thing in here was I have first put was this, and it complained bitterly about not finding this stuff. Wire, SPI, Rgb Matrix Panel, AdaFruit I2C device, right? And the custom header file, smiley tongue, right? Oh yeah, this is another thing. This particular demo out of the thing, the only one, will not fit on an Uno. You could think you flashed it to the Uno and nothing will work properly. But I went and added all these and solved the IntelliSense IntelliCode. Now, in theory, this should not be happening because CPP Properties states, look, I found the wire directory. I found the Chorus Arduino. I found blah, 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 right? See, all these PIO libdeps right here on the end, right? Rgb Matrix Panel, AdaFruit GVX library, AdaFruit bus IO. In theory, this thing should have found those headers where they belonged, right? What I found was not so. Oh, there's another property you can set. I have to find it, but notice how it closed the source code window in favor of the JSON window. Now it's opening the code window and getting rid of the JSON window. You can stop that from happening. You can then have both windows open on the top. I find that a bit annoying. It thinks it knows better than you. Usual crap. But yeah, before, having... We can check if this is going to blow this thing up. Okay? By just checking if we pull a problems out of it. And it looks like no. In this case, on this platform, for some reason, not the VM and not the Raspberry Pi, it's finding these headers, so I don't have to do that. But in case you run into this in Visual Studio Code where, damn it, it's not finding the headers. You know they're there, right? This is all about how this parses everything, right? How it determines path. And this gets more nasty in the Python side of the world on imports than it does on this side. And this, by the way, is a humongously large demo for the RGB matrices. I won't go into it much, but it's kind of cool. If you haven't seen matrix panels, let me go get one. Okay, so let's just park this window out of the way for a sec, the desktop. This is an RGB matrix panel. Okay, you have input, output, meaning you chain these things like so, off. And when you look at those big LED video walls you see put out, there are just a ton of these things. Not this particular size, because this is what's known as a, I believe, a P6. The P is the pitch between the LED dots in here. Doink, doink. So if you were to put a ruler on here, and I happen to have a measuring tape, and we were to measure, 6 millimeters. So this is a P6 panel. But guess what? In our office, we actually have what you would call a P.8. That's right, 0.8 pitch LEDs. So, and the wall is capable. It's like about 7 feet tall and roughly, I think, 12 feet wide, something like that, 14 feet wide. Solid wall. In those cases, those walls are not driven by these hub connectors per se. They're actually all big panels with self-contained units and stuff, and then they all link to a big driver system that controls it all. In our case, we have two different sets. One that's capable of doing 4K content, one that does 1080p. So two of them to do 4K, and the wall is split between the two, and then they're joined together in software to make it look like it's one seamless wall. And then the other are the walls divided in 4 chunks, usually a grid 1, 2, 3, 4, like so. And it goes and drives each section, and again, they're all tied together logically, and you get this effect where it looks like one big wall. Now, you can get these panels off AliExpress frickin' cheap these days if you want to play with this stuff. So a panel like this, which is 16, 32, this is only like about $8 to get this panel. To buy a 64 by 64 P2.5 panel, for example, you can get a really nice one from AdaFruits. It's about $35 or something like that. But on AliExpress, it's about a generic one is about $20, $18, something like that, Canadian. And I have the AdaFruit 64 by 64. I have my generic 32 by 32. I have this guy, and I have more coming. I actually bought some 64 this way, 128 this way, P2 panels. That's 2mm pitch. That's even finer than the 2.5 AdaFruit panel. So now you're saying, well, how do you drive these things? Well, that's the code on the screen. And there's a couple of ways of doing this. You can take this Mega, for example, and you can wire it. The wiring pattern is on AdaFruit's site, and you can connect it to this. But one key thing about all these panels, you need power. So I have over there, I have 2 power supplies over there that have, they're like 5 volt. One is, I think, 5 volt 12 amps, and one is 5 volt 6 amps, a smaller one. But you can get these things off AliExpress pretty cheap too. They range anywhere from $8-10 to about $30, depending on the amperage and the voltage you want. In these case, all these panels so far I've had are 5 volt panels. Right? Now they say that a 64 panel by 64 panel could draw as much as 7 amps. Well, one thing I've noticed is I had the panel with AdaFruit's Rgb Matrix Portal M4. This is one of their CircuitPython gizmos. Okay? So you plug the panel into this header here. Kind of like you look at this thing, you say input, and you go like that. That's the idea. I might have it backwards, actually. I cannot remember on this panel because for some reason this thing is not keyed, so it could actually go this way also. Let's see. Yeah, like that. Okay, and then the AdaFruit one, when you power it with the USB-C, just make sure that the USB-C power that's coming in here has lots of power. Okay, now USB 2.0 ports on a hub or something like that, they're limited to like 500 milliamps, unless it's a charging port, right? Or they have now different colors. So black is USB 2.0, blue is USB 3, yellow or even red. Those are power enhanced ports. They can provide more power. The other way to do this, of course, is you just use a Raspberry Pi 4 brick, 5 volts at 4 amps or something like that. The wall warts. Kind of like this guy right here, So this guy here is 5 volt 2 amps. This is a bit wimpy, okay, because it was intended for an older Raspberry Pi 3. You can tell because the link here is micro USB 2, right? What you really need is USB 3 effectively. I have that cable going to a USB 2 hub down here. So, but given enough power, you plug this all in, And this particular one, this big silver thing on here, that's Wi-Fi. So you can actually address this over the web in your hand and push stuff by web pages to this panel. That's one way of doing it. Sorry, that's method number 2 of doing it. Method 1 is direct, cables, right? Method number 3 is another concept from them. This here is an Arduino hat just specifically for Hub 75 connectivity. So what they've done on this thing, let's see if I can get a fairly good put. You can see that all the pins here on the thing are actually connected, and if you actually trace it out, they go to certain pins on the Arduino, both sides. Now, you do have to do a little soldering with this. So I added this part, the switch, the extra 5-volt input that you might need. They didn't have to put this on, but I put this part on because I needed another ground pin. And there is one in here. So they would have you line up the Hub 75 ground pins, these green guys here. Plus, depending on the panel you have, you might have 3 address lines, 4 address lines, or 5 address lines. So the 64 by 64 panel, for example, has 5 address lines. But the 32 by 32 has 4 address lines. And this guy here has 3 address lines, but it demands that the 4th address line, D, be grounded. So I made this guy here with a jumper block. If I don't put anything in here, right, and instead I go from here to over here to the ground, I've got my extra ground. Unless I do another panel, I need that extra address line. I just jumper over these two, and voila, the thing becomes address line D. So you get a ribbon cable. I don't have one on my desk at the moment. And you put a ribbon, and it's keyed. There's a key right here where my finger is. So this goes on top of a Raspberry Pi. Sorry, I mean Arduino. So like this. So now remember what I said. This particular demo, the Panel GFX demo, none of the others, just that particular one, is so packed with code, you'll overload the Arduino Unos. You need to put this on the Mega. Now, the funky thing about this, the actual pins that get used on here, you could make it technically work on here. Because if you look at a Mega, like so, this part of the pinning in the Mega is almost identical to an Uno. But the code would have to be modified because the code uses some stuff over here, some stuff over here. Okay? So what I'm going to do, and I've ordered and I don't have it here yet, is I've got the Hub 75 style standard ribbon thingy connector, and I've got hats coming for Megas. So I can build this on here. And I have over there, I just don't have it over here, I have a Mega hooked up to the 32 by 32 panel running the panel. Now, there is a 4th method for doing this, also from AdaFruit. So far, all we've done is we've messed with Arduinos. Now, Raspberry Pis, and let me go and get Mr. Chrome here for a sec. See if I can get Chrome. Oh, Chrome's not even running. Better not do that. That's a bad thing. Let's go get Chrome up. So, if we go looking on Chrome, and we want to find AdaFruit Rgb Matrix Pi. Matrix hat plus RTC for the Raspberry Pi. So let me get a picture of that for you. Okay. Okay, let's show the desktop again. So this is the panel I have basically, but I think I'm not sure in this demonstration whether they have this panel is the 2.5 panel or not. Yes, it is. No, brass M 2.5 also includes GPU ribbon. AdaFruit Rgb by mini kit. Okay, so no, there's no panel on this, but the 64 by 64 panel kind of looks like this. Okay. Now that piece up there, you have to do a bit of soldering. So let me see if I can find a picture of it. So this is what you get. Okay. This piece up here, the female header, goes actually underneath the board. It's going to be the piece that plugs into the Raspberry Pi. This is the extra 5 volt right here. And this is the hub connector that goes over here. Now, this is a Rev C hat. You can see the little... Why were you always doing this? I don't want you to... Blah. Don't you hate it when you have auto zoom? There's a little C there on the thing. I try to point at it, but this stupid thing is zooming the picture all the time. Open image and new tab. There. So this right there, this C revision. What it does, this is the E address line setup right here. So you will have to solder 8 to center. Now I really wish that AdaFruit instead put a jumper block here. You don't really need the time clock, but if you do put it on the thing, you can. It just takes a particular battery cell. 2220 or something like that. I can't remember the number. The other thing you might want to do on here, there's a quality thing on here where they want to have pin 4 here and pin 18 here soldered. I highly suggest instead go to your thing for headers, for male pin headers, and just put one in here and one in here so that you can just jumper a wire across when you need to. Again, I really wish these guys would have put that as a jumper block in here. You know, rigged it somewhere in here where they just had a jumper block. If you jumpered this, 8 and 18 were sealed. If you jumpered over here on 8 and center, that way you can take it off and take it on anytime you want. So you build this thing. This is the bottom of it, what it looks like. They give you a gap for the ribbon for the camera, just in case. But I'll warn you this. When you run any of these matrix stuff like this on the Raspberry Pi, it's very, very sensitive to what you run on the Pi. I had to turn off the desktop and some other stuff, including the onboard audio. Not that I cannot use audio, I just have to use it now through a USB audio device, not the onboard one. The thing is so sensitive to timing that it'll look like your panel doesn't work. Right? But this is method number 4, and it works quite well once you understand how this all goes together. So, and there's where it looks like when it sits on top of a Pi. Okay? Now, if you supply this thing with its auxiliary 5 volts, these cables, just like on this one, let me turn off the Chrome for a sec. Just like on this one, I've got the power connected here on this one. So it's actually getting the panel power from this USB-C port right there. It's the same thing with this, right? And this one. If I supply, from a DC supply of 5 volts and certain amount of amperage, I can power the panel from here. Or you do it from here. Like you put it on here, like so. You put your 5 volts in here. This picks it up. This goes to the panel. That's one way. Or like I did, I have standalone power supplies doing this. So, and that code drives all this. So all this code here. These are just samples. And I fiddle a bit with the samples. I even got, I changed things where I figured out a lot of ins and outs of how the code worked. It's kind of tricky at first because you have to actually know panel sizes, how panels work, right? You have to really pay attention when they tell you that the mega panels, Arduinos, these guys use clock 8, for example, here in the code. You have to add a defined D in here for A3, put it in here into the matrix because that panel required 4 address lines, right? In theory, you could add E into here and get, the 5th address line. So now this guy here, I show just below the code window in the gap. This guy here, he uses CircuitPython instead. Okay. Now, do I have a USB-C cable here? Give me a sec. I need another USB cable. Okay. So we have somewhere down there. There we go. This guy, USB-C. So, and I happen to have a USB 3 hub here. And we'll plug it in. And what happens with these units is they actually have storage on board. So you see the CircuitPy? I'm going to mount it. Okay. So it's mounted. Now I'm going to close this workspace off. Close workspace. Okay. And I'm going to open a folder. So what we want to open is that. Let's see, other locations, computer, media. Where is Mr. Media? There it is. Will M, CircuitPython. Okay. So the way this works is, yeah, we'll open that workspace file. There we go. So this is all Python code. It's derived off MicroPython, and AdaFruit morphed it into CircuitPython. So all the stuff needed to run something is on this unit. Okay. Code is the default code where you run all your programs from. Now you might notice I have code 0, 0A1 because I was messing around big time. Okay. So first thing I see in here, and I need a shell. New terminal. I have 11 problems detected. So what we have here is the notorious Python linter. Whining and complaining and complaining and whining. Both these things are complaining. So Pylance is complaining and Flake is complaining. We're going to fix both of those things. So what we want in here is settings JSON. I believe is what I want. And I need my console for a bit. So I've already fixed this before in another project. So let me see if I can find it. Python ls misla cd rpi ls misla. Yeah, here. So this was a RGB library for the Raspberry Pi. And what I'm going to do is go to bindings and Python samples No, not quite. Where did I store that? Oh, this is a fresh copy. So we need to be in to 192.168.42.60. Oh, just a sec. We go to the black screen because I have to type secret, super secret stuff. There we go. So bring the desktop back and the top cam back. There we go. So this is the VM on the Windows machine. We're going to borrow it for a sec because we need to get something out of it. Do I have the other Python up? I do. Let's just check. Yeah. Okay. I'll get it from another spot too. So this Visual Code Studio is actually remotely connected to my Pi, and I'm going to dip into it for some stuff. What I need out of this thing is not that file. I need settings JSON. Okay, here we go. In Pylance, to fix the Pylance errors, this took me a while to figure out, and it was annoying as hell. See this one? Autocomplete extra path and analysis extra path. Right? And this is the flake. So what we're going to do is we're going to steal this chunk of code here. Actually, we'll steal the comma too. Control C. And we'll go back to the other one. No, not the console window, William. The other code, this one. So we stole that code out of settings.json under .r open projects. Really what it is this stupid file here. We need the Python VSCode, not system volume information. I'm pretty sure I can shove it into here. Not quite. We need a spot to drop this in. Our problem is we need to fix the path. Well, I can take this part one, this one here, the flake args. That's an important one. Come on, cut it out. Control C. So we go back to this one here. Make sure I'm in the right settings. It could be that flake args is not installed and this guy quite right. Problems. Oh, we're down to one problem now. Oh. See, this is the part where I hate about the bracket lineups. This needs to be down here, I believe, actually. And that needs a comma. There we go. Like so. Okay, so basically we've got rid of the flake 8R linter. All this really does is say ignore all these types of errors or warnings or whatever you wish to call the dumb things. I mean, I don't understand why they say, well, you have to have a new line after the end of the file. Oh, give me a break. This is not Windows where everything has to have carriage turn line feeds at the end. So we basically fixed the thing. Now, it's the same thing with the, this is the other part in Python that gets annoying. So you see these autocompletes here. This is a Pylance problem. There are two Python engines, language engines, so to speak, in Visual Studio that get used. Jedi or Pylance. And you can actually check which one you actually have. So you go Pylance. Right? Microsoft Pylance, performance-rich language server for Python and VS Code. Blah. Except when it doesn't want to work. Right? Which is usually, you get these stupid IntelliSense, IntelliCode warnings saying, I can't find something, an import is missing, blah, 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 blah. All this stupid crap, and it actually doesn't exist that way. So in our case, on the local machine here, when you look at code, so it's complaining here about something new. This is flake. So we need to find, I thought I fixed this already in JSON's. Let us have this rebuild this. Did I have to put that in CPP or settings? I can never remember. VSCode settings. Yeah, I had a flake args in the settings file, and I got rid of it over here there. Now, see, the stupid thing, this doesn't do this wrong over on, but we can fix this, I hope. So, why aren't you picking up the settings JSON file? Again, let's go and IntelliSense, reset the IntelliSense database. Okay, F1 IntelliSense. I just want to make sure. So they are using Flake 8. Let's just change this to Pylent. Let's install Pylent instead. I always found Flake not working very well. Okay, so we're down to 3 in code problems. Missing imports. The classical problem, board. We know it's there. So what we're going to do is in our settings JSON file here, right here, we are going to add from the other one, one of these parameters here, but we're going to modify them a bit. I have a feeling the path is just kind of wrong. So we'll Control C this, and we'll go over here. And we'll Control V it, and we'll get rid of the last colon. Now we have to straighten the paths out. So it doesn't know what this is. Expected a comma. Oh yeah, of course, duh. Comma. Okay. So home will M work code Python. No, this is not what we're looking for. In this particular code space, we need the path, as I said, where is it? Home, root, media, will circuit pi. This is the path we need. So Control C. And what we need in here is Control V. And I don't think I need these guys. We'll find out in a sec. And here, Control V, get rid of this part, Control S. So we still doesn't like it. Board, display IO, frame buffer. Okay, so we need to go a little deeper. And those are actually in the lib directory. Should be in the lib directory. So this is the part of Python I kind of hate. It's like very annoying. So when we go look at CodePy, we want to import board. Where does it get board from? Oh, board. Where are you coming from? So on the 211, this workspace, this is not the code one. This is this is the Rgb Matrix code space. Do I have? No, I don't have. I have it over here, so I can't do that. We need to find these. So font, bus, device, display, I/O, matrix, portal, portal base, graphics, network, devices, the wireless cup, that's what that is. Graphics, matrix, no, we don't need any of that. Portal base, no. No, that's the compiled file. Well, that's kind of funky. We're missing something that shouldn't be missing. Not good. Display I/O though, I think I can fix that one. AdaFruit I/O. Problem is, where is that stuff? CD media. Lib. Grep board star. Matrix has it, and Wi-Fi has it. What was the other one? Oops, not that. Display I/O. Display. See, this is what I don't like about Pylance. If I switch the thing, I think I can switch this. If I switch it to Jedi, I think the problems will just simply go away. I've actually put a very displeasing survey into them about this. Set What was it? Lang, no. Lang. Where was that? So linting pilot enabled, flake. Where was the other one? There's another file that contains, oh, damn it. It's not in this one. Probably so many possible settings. Language. No, come on, guys. No. Oh, I have to look this up. This is stupid. Where's my Chrome? Visual Studio Code. Change Python language server. Terminal launch, no. Logging level, workspace tags. No code. TeleSense engine settings. Language server. This is what we're after, actually. Just gonna park this on another window for a sec. What we really want is Python. Yes, we're on pilots. We need to change that. Oh, this is starting to annoy me. Cord gets getting caught under the keyboard. It's not quite what I wanted. There, Python language server. We don't want that one. Let's change this. Let's see what happens now. Go back to code. What do you mean you don't like my comments? What are you bloody well complaining about now? I need a notepad. We need a notepad. Utilities. Give me K right, please. Control V. All this is no go anymore. Control C. Control V. Delete. 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 Okay. Oh, stupid Flake 8. Oh, man alive. I thought I got rid of all that. I think I need this chunk now back. Control C. Home. Comma. Control S. Oh, what a mess. This is what I really hate about Pylance and Jedi. Get them wrong, and it's all a mess. And then import, import board could not be resolved. That's all default settings. You're complaining about crap in here. Correct string type. Okay. That's, who cares? Get rid of that. What we care about is this one. Undefined false on this. Python linting. So you don't like the lint variables. Okay, fine. Okay. I don't need default settings. Go away. File save all. Well, that's another frickin' bug. I don't have an unsaved file, you stupid smucks. No thanks. Select the Python interpreter. Can we have the correct one, please? Okay, so what we did is we lost the mount point. Okay, USB key, CircuitPython. It's still mounted. Retry. So why can't we save to that directory? Is it one problem? It's another one. CD media. Wilm, CircuitPython, LSFLA. Well, that's good. Hi, I'm empty now. Something happened there. LS, CircuitPython. There we go. All our code's back. That's fine. Okay. Let's add the folder back again. Yes. Another chunk of crap that has to be installed. And we're back to Flake again. So I wonder if now I can get rid of Flake. No. Whoops. I want those guys. Control C. Can I not put these back in here? Come on. Tree. You don't like these anymore. Ah. Holy fuck. E226? Ah, come on. Give me a break. It's probably because it thinks it's in one form of the code and it's in another. Oh, look. Rgb Matrix is found. Duh. So we don't care. E221. Let's add another one into here. Comma E221. Control S. There we go. Comma E226. Control S. Line break W504. W504. Control S. Trailing white space W291, comma W291. We'll keep adding these in. Now we're back to E222 multi-space for operator. Yeah, whatever E222. Now we're back to our missing imports. I'll have to have a look at this later. This is really stupid. File, save all. There we go. Okay, so now this doesn't work over there on that project, so why are we missing the board? So I know that AdaFruit has changed the way they bundle things. So if you're working on a project like this now, they changed at the top. You can actually, when you do the code samples, you can actually get a complete zip you can drop in place in your circuit Python directory like this, and it has all the files you're supposed to need. Now they just did this, like it's really new. But this is the part I hate. I think board is there. It's just that it's not finding it properly. So now we're doing Magic Python with Pylance. So I think we're doing Pylance. Where's my editor again? So let's put that chunk back in here, comma, Control V. Okay, so right, stupid JSON. try to make things pretty, and of course it doesn't like things. Control S. There we go. So our paths are not quite right. What if we add lib into here? No, I do an import here. See, no board. No, it does. The IntelliSense is not finding. You can see right here. It's not finding it. So, whoops! I need the browser for a sec. Where's Mr. Browser? There it is. Circuit Python. Not finding board. Import board. Let's see what they have here. Windows 10, Windows 7, Mac OS. Drive issues, no. Easy way to storage, trace files, no. 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 Not helping. Yeah, that's what I know. The module display. I have the most pretty well current Circuit Python, so that's not the problem. Just check that. Yeah, it's right there. It's probably something I'll have to debug on this particular machine, because I know it works if I plug it in over there on the Raspberry Pi, because that's where I was using it. But this is the Python hell that you can go through with imports. It's just annoying. I know board display IO frame, but for port B, yeah, of course not. I just put that in there, right? But this usually can get solved by these types of lines right here with Pylint. It's just the problem is we're not finding them at the moment. I wonder if this is missing. Oh! There's something that came up. This came up with someone else had a problem with this. It turns out possibly what we're missing here is at the Python level. pip3 install. Is it Blinka? Python 3 pip install blink. Yeah, AdaFruit Blinka. So let's try this. pip3 install AdaFruit blink. Some of the stuff actually comes from the stock stuff. Now let's go back to the shell and see what happens here. No, not the remote one, the local one. File save all. Let's just open code again. We might have to restart the environment after you do that, like that. So let's go open the workspace again. Recent CircuitPy workspace, open that up. Better. So we've solved the board issue. Okay, so now we need to solve the display I/O issue. Because it's actually not in the CircuitPython's lib directory on the device. It's actually in your OS. Good thing I remembered that. So we need to do the display I/O. Display I/O. Oh, okay. So again, we should actually be able to do it in here too. Pip3 install AdaFruit link display I/O. And then we probably want Linky A, not display I/O, but frame buffer I/O. See, nope, not quite. Exit this. Let's come back in again. And file, open works, resend. Workspace. Let's see if that solved everything. No, we still one more to go. Frame buffer I/O. Whose? AdaFruit, unless this is a stock one. AdaFruit CircuitPython frame buff. Let's try that. You know, I should be able to install all the CircuitPython stuff into here. Apt install circuit. No, Python 3 circuit. No. Let's just see. Python 3 install Circuit Python. Installing Circuit Python. That's the library bundle. Okay. Python. Oh, come on, guys. I hate propaganda pages. Kind of want to Circuit Python. Yeah, I know all that. Creating anything Python library. Library bundle. No, this is. Okay, let's just borrow the Raspberry Pis. Let's see what. Yeah, I've done all that. Let's try this. That's much better. Okay, so we don't want the Raspberry Pi Blinka. We don't need any of that. Let's see now. This guy here. Close it here. Start it here again. File recent. Do we still have an error with the buffer IO? We still do. We're still missing a Python library. We installed all that shit, but it's not working. Okay. Okay, AdaFruit. Install a real or virtual Linux machine, native Linux. Okay. Yeah. I'm not doing a Mac OS. So, native Linux. Okay. No, that's installing Ubuntu, you dummies. Apt install. There's got to be a missing piece here. Apt install Python 3 dash. No. We are missing one frickin' library. One. I don't want to do ARM. I just want to do that missing library. Apt install. Apt install Python 3-ada. No. Python dash no add. What the hell? It's all in the py. Okay. Pip 3 install ada. Platform detect pure IO. Python shell. Blinko platform detect. Install. Just put that in just in case. And that. Okay, those are all in. That leaves the frame buff. Fasteners feature. Is there one called buff in here? Nope. Frame buffer IO. Oh, come on. Damn it. There's one library short of load here. Missing import. No, I didn't mean that. Yeah. Download the library bundle. Yeah, upload code. Where the frick is it getting frame buffer IO from? I know I'm missing something. God damn it. This is stupid. Oh, brother. You know, there's a real problem with this frickin' Google and the bad sites now. The phishing attempts. No, I meant frame buffer IO, Google, not frame buffer. Okay, let's try this one. Pip 3 install AdaFruit dash circuit Python dash frame buff. Okay, let's see what happens now. Crash and burn time. Bring this open. File, open recent workspace, please. Thank you. Stop! Come off it. Oh, man. Let's try this again. Open recent. Still doing it. This sounds like this is the stock frame buffer IO, not AdaFruit's version of it. But where in the hell is it, the package? Stupid Google. Where in the hell is this? Digital I/O? Where in the hell is this library? Oh, come on with the fucking bad sites. Man. Where in the hell does it come from? Oh, I hate frickin' PDFs full of crap. I wonder. Let's go over here. No, this is doing Arduino. William. Forget it. That's stupid. E303. Go away. Blink. Code. AdaFruit. buff. No, it's not there. Not there. Oh boy. Why does it work over there on the Raspberry and it doesn't work over here? Ah, this is just crap. Python 3, what provides frame buffer IO? Definitely in the MicroPython one. Stack Overflow. Let's see what they have to say. Nope, no good. Yeah, and the dumb thing is this thing all works on Raspberry Pi just fine. I wonder. Electron, let's go to the Pi. Ch Pi at 192.168.211. Console. Okay. Okay. Apt cache search for frame buffer. Python 3 SDL2. Virtual frame buffer. So we have a Python, SDL2. We have these guys, Python 3 SDL2 and Python 3 XV frame buffer wrapper. Now, what is the method? pip3 show installed. No, that's not what I want, guys. Why do you guys just frickin' do this all the time? pip3 show install packages. How to list install package. Thank you. Good old active state. pip3 list. What we're interested in here is Plus pointing to the blinker. Blank T. Jedi, Jupiter, lazy. Parsing. Okay. I think I'm going to call it here. I obviously got a problem on this particular box. It's not finding things. I'm missing stuff. Don't know how to get it in yet. Did fix 2 board and display I/O, but still don't have frame buffer I/O. And it's supposed to be here. So I'll try again later. I have to research this. Where is my thing? Okay, so this will be the end for the moment.